In this presentation, I'm going to talk about data collection. The first one is a case study. A case study is basically an in-depth study focusing on one individual, or it could be a group, and is often in real-life context. It's very, very detailed, and there is no manipulation of anything during the research by the researcher, so they won't change anything that will potentially affect the results. It's a narrative account and sometimes can contain measurements, but usually it's just words. It's narrative. The evidence that's given is what the subject tells you as a researcher, or what you see, and this will be the evidence. So there's no kind of figures like there would be in experimental, which I'll talk about later. It is just words and written down, and because of this, the study can have low reliability, and it's subjective or biased, if you like, and this is because the researcher is basically basing the evidence on what people tell you or what you can see. So sometimes it can be a bit unreliable, but an advantage of a case study is that it's very real, and it gives you real insights as well. An example of a case study, you could do a study on an Olympic champion, so the best in the world, to see why and how they became the best gymnast in the world. So it would be very in-depth and focused on that one person. So you'd look at a range of different things, if it's their personality, how committed they are, their natural skill, personal reasons, all their kind of different fitness components as well. So yeah, it would be very in-depth and just focused on them. The next one is cross-sectional. Cross-sectional is basically when you collect data from a cross-section of a population at one point in time. That's very key to remember. It's at one point in time. It's just basically kind of a snapshot of what it's like. Cross-sectional research studies are based on observation that take place in different groups at one time. There's no experimental procedure, so no variables are manipulated by the researcher. Instead of performing experiments, you'd simply record the information that you observe, so what the researcher can see. But it cannot be used to determine any relationship that may exist. So this would be a disadvantage of using this. But on the other hand, as an advantage of this, that it can suggest a cause and effect of why this is happening. But again, nothing can actually. So basically, what this study allows you to do is to look at different groups of individuals and basically compare and contrast. So as an example that I've got is that you could be to look at two different groups of gymnasts. One group who are women aged 12 to 17 who compete at national level, and the other who are men who are aged 12 to 17 and compete at national level also, and see if girls are more prone to osteoporosis or men are. So we're looking at two different groups who obviously aren't the same, because one group's male and female, male, and one group's female, but they're both at the same kind of level and compete in the same sport, so they're very similar. The next one is longitudinal. This is where subjects are followed over time with continuous or repeated monitoring. So these tests can last for weeks, years, or even actually decades as well, so they can last for quite a long time. The same individuals are observed over the study, and the researcher looks for developments or changes, and these are detected by the researcher again, and then they're recorded. But the researcher doesn't intervene, they just observe. So again, there's no kind of manipulation or anything. It's just left down to the subjects to kind of do their thing, and the researcher just observe, again detect any changes or developments. And a slight disadvantage of using this is nothing can actually be proved from this. An example that I have is to measure osteoporosis levels or increases in a group of young female gymnasts. So you're basically watching them from a young age until they kind of grow up and see if the levels increase, etc. The next one is correlational study. This study is quantitative research, and it determines whether or not two variables are correlated or related, if you like. So it sees if an increase or a decrease in one variable will have an effect on another variable. So will that other variable increase or decrease? We measure correlation between -1 and +1. The closer it is to -1, the less correlation, so negative correlation, and the closer to +1, the more correlation, so it would be positive correlation. And a disadvantage of using this is that it can only uncover a relationship, so it can't actually provide a conclusive reason for why the relationship exists, if that makes sense. You can also use correlational in validity and reliability as well. So it's used in validity when you're looking for a correlation between, say, a new measure and an established measure. For example, if you had someone came up with a new machine to measure body fat, you would see the correlation between an existing one that's established, and you could see the difference in results. If it's the same results, then obviously we know this new machine is very good, but if they're completely different, then obviously it needs some work doing to it. And then reliability, it's just basically to see if measures and observations are consistent. So yeah, and an example of this, I've got one that is to see if an increase in creatine supplementation has an effect on performance. So you're seeing the difference. And there's another one. It is very unethical and no one should use it, but it's quite a good one. So you could see if a calcium, if you decreased your level intake of calcium, would there be a higher rate of injury? But this is very unethical and shouldn't really be used. And other ones could be such as height and flexibility, or thigh girth and vertical jump. And the last one is experiment. And this is the main method used by a scientist, and it's quantitative research. There's two important elements of this study. It's manipulation and control. The manipulation part is when the researcher purposely changes a factor, which is the independent variable, and this will affect the results. And the other is, and this is where you keep all the other variables, so the dependent variables, controlled, and the extraneous variables, these should also be controlled. And extraneous variables are basically the variables that aren't the independent variable but could still affect the results, so kind of outside factors, and you want to kind of keep these controlled. There are two ways that experiments could be carried out. It could be a field experiment, and this is when you do the experiment in the same environment as the participants are used to. So if it's gymnast, it would be in a gymnast centre kind of thing, and this would increase the ecological validity of it as well. And the other is a lab experiment, which is where you do it in a lab, and obviously the ecological validity wouldn't be so high here. An example of experiment study could be to see if gymnasts are more flexible when warmed up compared to when they're not. So here, you can get an exact figure of their flexibility using the sit and reach test before they've warmed up and after they're warmed up, and you can see a comparison very easily from that. An advantage of using this is it establishes a cause and effect. And that concludes everything. Thank you.